Welcome back. Today we're going to discuss section 2.4, derivatives of exponential functions. Remember, exponential functions at this point in time, f of x is going to equal e to some variable. We've looked at x at this point in time. But today we're going to change that exponent, and it's going to be something that's going to be a function of x. So it's no longer going to be that single variable. So we're going to look at how do we find that derivative. This is also going to go into another part of our chain rule, of course, section 2.4. So our critical information, we've talked about the derivative of a single variable of e. The derivative, d dx of e to the x, is equal to e to the x. Well, what happens when that exponent is a function of x? So what happens if maybe we had x squared plus 3 in that case? So we aren't just going to get then the same e to the x squared plus 3. This is actually another chain rule where we have e to a function. So the derivative, or d dx of e to the u, where u is a function of x. So this is going to be, say, u equals f of x equals this x squared plus 3 that we were talking about. So how do we find that derivative? Well, again, we're going to take the derivative of that exponent, we're going to bring it to the front, and then we're going to multiply that by e to that same exponent. So one of the biggest things I want you to take away here is that the exponent of e will never change. The exponent of e will never change. I cannot say that enough. The exponent of e will never change. So if it's e to the x squared plus 3 in our problem, when we're looking for the derivative, in our derivative, that exponent will stay x squared plus 3. Doesn't matter what it is. So let's go ahead and look through a couple of examples and see how this is going to play out for us. So in example 1, we're asking to derive f of x equals 2e to the negative x minus 3x plus 2. So we should see that we're going to break this up into 3 different parts. We're going to find the derivative of each individual part, in which we can do that. So 2e to the negative x, we're going to take the derivative. 2 is just a constant, coefficient, so we don't have to worry about a product rule in this case. E to the negative x, the derivative of negative x is negative 1. We're going to multiply that to our 2, and we're going to end up with a negative 2. We're going to multiply by e to that same exponent, e to the negative x. Derivative of negative 3x gives us negative 3. Derivative of 2 is 0. So that's going to be a good enough answer for us. However, if it's multiple choice, we might see it as negative 2 over e to the x minus 3. You may also see it as a common denominator of negative 2 minus 3 e to the x all over e to the x. Again, extended response, any one of those would be acceptable. I personally would leave it. Once we've answered the question, we leave it and we're done. In example 2, just have a few examples left here. We're going to ask you to find the derivative of e to the sine of x. So yes, we can put the trig functions in our exponents as well. So we can do that. I know you can. Derivative of sine of x, the derivative of sine is cosine. So we have the cosine of x, and we're going to multiply it by e. Again, the exponent of e will not change. It will say e to the sine of x, and that's going to be our derivative. Example 3, we're going to now derive e to the 3x minus 1 and multiplied by the sine of 2x. So here we've got a couple of different chain rules. We have an e to an exponent that is a function. We also have the sine of an angle that's not just a variable, a single variable. So those are going to cause us a little bit of issue. We also see that we have a multiplication sign between them, and we have variables in each part. So we're going to do the product rule as well. Oh, juicy juice. So f prime of x. Remember, our derivative for product rule is 1d2 plus 2 d1. So we're going to rewrite the first term, e to the 3x minus 1. We're going to take the derivative of the sine of 2x. So the derivative of a sine, we take derivative of the trig function, which gives us cosine. The angle does not change. So remember, the angle does not change, and the exponent of e does not change. But we do need to multiply by the derivative of the angle. So the derivative of 2x gives us 2. To that, we're going to add the second part, the second term, the sine of 2x. And then we're going to take the derivative of e to the 3x minus 1. Derivative of 3x minus 1 is 3. E, and then again, that exponent of e is not going to change. Again, this would be a good enough answer for us. However, we could possibly see it. We could see that we have an e to the 3x minus 1 that's in common with each of those terms. So we could put that like so. Now we have 2 cosine of 2x, put that in parentheses if you wish, plus 3 sines of 2x. And that's, again, going to be a good enough answer. You could do your double angles. We really don't worry about that too much at this point in time. Again, we're interested in what the derivative is. In example 4, we're looking for the equation of the tangent line to the graph of e to the 3e to the 2x minus 1 when x equals 1. So recall, to find the equation of the tangent line, we need a point and we need the slope. Our point, we know x equals 1, part of that point. We can also go ahead and find the y value by finding f of 1. So we have 3e to the 2 times 1 minus 1, which gives us 1. So we end up with 3e. Not very nice and clean looking, however, that's our point. So that's what we deal with. Go ahead and find our first derivative, f prime of x. Derivative here, we're going to multiply again the derivative of 2x minus 1 to our coefficient, since it's just a constant coefficient, which is going to be 2 times 3 gives us 6. E, again, the exponent's not going to change. We can go ahead and find their slope then. We're interested when x equals 1. So we have 6e to the 2 times 1 minus 1, which gives us 1, or 6e. So we can go ahead and write our equation. Y minus 3e equals 6e times x minus 1. Again, good enough answer. However, if you want to play around with it, we can. I might bore some of you, or some of you may think, where is all that coming from? So we can distribute the 6e through the x minus 1. We can add 3e to it, so we get y equals 6ex, then minus a 3e. We could also factor out as 3e in this case, I guess, if you want it. Just kind of depends on what the multiple choice answers look like and what we have to manipulate in order to get to one of our chosen answers. And that gives you a little bit of a chain rule with our exponential bases other than e. Enjoy and good luck!